So I'm going to first start with an apology because this lesson's a little bit longer than typical because of the timing of the quizzes. It's two lessons together to start, and then both lessons happen to have a lot of vocabulary words. So there's going to be a little bit of extra writing. So you're probably going to have to pause the video to get all of the definitions, but it will be worth it when you get an awesome score on that quiz. Both of these quizzes. So the first topic is volcanic eruptions. So I put a little note down there. We've been talking about the eruptions, but just a reminder of how they happen. So you have the trapped gases that are down in the magma. Once you put them under pressure, they are going to come up and erupt. So just a little note about how those eruptions are happening. Then you can already see this second slide here has a lot of vocab on it. So I do have a picture here. The picture does have two probably slight differences from Edgenuity, which I'll point out, but I still thought it was a good visual. I know for me, I like to be able to visualize. So I'm going to start with the vocab words that's actually underneath the Earth's crust at the bottom and work my way up. So the first term is the magma chamber. So that is all the way below the Earth's crust, and that's where the magma is stored. It's a little pocket. And if you know what the word chamber means, chamber is where things are kept. So it makes sense that a magma chamber would be where the magma is stored. And this would be even not during an eruption. That's where you're going to have the magma. So the next term they don't actually have labeled on here is the word pipe. So Edgenuity considers the pipe the entire tube where the magma travels up to the surface. So they would call this the entire tube. Next, this is where you're going to see the difference. If you see where they have vent labeled, Edgenuity would probably consider that the pipe. Edgenuity is saying that the vent is closer to the opening. So the vent is the opening where the molten rock and gas will start to leave the volcano. Then we have the crater, which they do have labeled at the opening. So it's at the opening and it's that bowl shaped. And then you have the caldera. That's where the lava starts to cool at the top. So Edgenuity would say that the vent, the crater, and the caldera are all near this opening up here. Then lastly is the lava flow. So lava flow is where that lava starts to come out and move down the side of the volcano. So just to kind of sum up, starting below the Earth's surface, the magma chamber is where the magma is stored. The pipe is that tube that goes the entire way up the volcano. The vent would be where the opening where the molten rock starts to leave the volcano. The crater is that bowl shape where it starts to leave. And the caldera is when the lava starts to cool at the opening. And then the lava flow is what we're used to seeing if you've seen a video of a volcanic eruption. The lava that comes down, it typically comes down on both sides of the volcano. So our next slide. So they talk about two types of eruptions, quiet and explosive. So a quiet eruption is going to have low silica and it's going to flow very easily. So this goes back to our last lesson about viscosity. So a quiet eruption is going to have a low viscosity, which we talked about. That is the lower silica, less silica. So because there's less of those particles, it's going to flow really easily and it's going to flow much faster. So it causes those lava flows. Whereas an explosive, this is where they get a little more dangerous. It's high in silica, which means it has a high viscosity. So it's not going to flow as easily. Because there's more particles, it's not flowing as easily, it's flowing slower, but it's going to be more dynamic. So that's where they become explosive. All those particles, all that silica is ready to explode. Another term that goes along with the explosive is the pyroclastic flow, and that's going to describe the eruption of rock, ash, cinders, and gases. So the quiet eruption, you're not going to have as many of the rock, the cinders, and the gases. It's more of just a lava flow that's going to be less explosive. Next, they talk about the volcano life cycle. So as a volcano is started, it's going to start active. That means it's erupted within the past 200 years, and they're the most dangerous. And scientists will say that an active volcano is going to erupt again. Then we can have a dormant stage. So whenever I think of the word dormant, I think of asleep. So in a dormant volcano, it hasn't erupted in 200 years, but scientists have used clues to show that it's still probably going to erupt at some point. So even though it hasn't erupted in the past 200 years, they look at temperature and pressure below the Earth's surface and they're thinking, yeah, that one's not extinct. That one's going to erupt again. And then the third type is extinct. It hasn't erupted in millions of years. And using those clues of temperature and pressure, scientists don't think it will ever erupt again. So an extinct is not really a worry. So active are, it's erupted in the last 200 years, they're dangerous, it's most likely going to erupt again. Dormant, even though it hasn't erupted in the past 200 years, using the temperature and pressure clues, scientists are pretty sure that one's going to erupt again. Extinct, millions of years have gone by without an eruption, and scientists don't think it's going to erupt again. So what are some hazards of volcanoes? So in the quiet volcano, we talked about because it's flowing on a slower pace, that lava flow can still cause damage. Even though it's not the huge eruption, as you can imagine, lava can cause damage. Another hazard, and this might be more of the explosive, would be volcanic ash. So it's rocky particles that are the size of sand. But if you picture that in the air near where people live, that could be a hazard. There can be toxic gases. And then even, and typically before an eruption, there might be small earthquakes. That would be, could cause a hazard. So moving into the second lesson, so there'll be a separate quiz on this topic. This is volcanic landforms, and this is the last lesson in the volcanoes unit. So first, I'm going to talk about the 3 types of volcanoes or mountains, depending whether it's active or dormant, that can be created when volcanoes start to erupt. And I actually put the picture from the practice activity because I didn't know how clear it was. So it is on the left is A, then the middle is B and C, and I lined them up with the 3 types. So this A over here, they have a clue, they wrote the word cinders. That's going to be your cinder cone. That's going to be pretty steep, maybe not really, really tall, but it's going to be the steep hill. Ashes and cinders start to build up around the opening, around the vent, and cinder cone volcanoes are going to be pretty explosive. Those are the explosive ones, the ash and cinder coming out. That middle picture there, B, is going to be the composite. You're going to see it's going to get a little bit taller. It's going to be a little cone-shaped, and it's kind of the mix between the two. So it's going to alternate between layers of lava and layers of ash. So depending on whether it's the layers of lava, which will be quieter, or the layers of ash, which are more explosive, it kind of goes back and forth between the two, which is where you're kind of getting more of that height. And then C there is going to be the shield volcano. So it's wider, it's more gently sloping. So it's one of those quiet eruptions that have the lava flow. So it's not going to be as tall, it's not going to be the explosive. The Hawaiian Islands actually have a lot of shield volcanoes. So looking at the 3 types, the cinder cone is going to be the really explosive. You got the ash, the cinders. The shield is the quiet, which are those slow moving layers of lava. And then the composite is the middle. So it's getting taller. It's still cone shaped, but it's getting taller, and it's alternating between the 2 types. So if it's going to be quiet, you're having layers of lava coming. So you can see the layers down here in the picture. So you have a layer of lava, a layer of ash, a layer of lava, a layer of ash. So it's kind of the combination of the explosive and quiet. So our next is just some other landforms. Again, a lot of vocabulary, I'm sorry. So the batholith, that's when a rock forms when the magma is cooling in the crust. So it's really a rock formation. If you see it, it's not looking like a mountain. It's more of a rock formation. The caldera, which I mentioned this is a part of a volcano. It's the hole at the top. And when that chamber starts to collapse, with the chamber is bowl-shaped, if it's starting to collapse, that's when we get the caldera. A volcanic neck is when the magma hardens in the volcano's pike. And then dike and sill, I want to go over because they're very similar. So I put in all caps the words that are different. That's how similar they are. So a dike is rock formed. So they're both rock formations again, when magma forces itself across rock layers. This is going to be in a vertical cooling motion. Whereas the sill is when rock is formed, when magma squeezes itself between layers. And this is going to be on a horizontal cooling level. So the dike is forcing across the layers in a vertical manner. The sill is squeezing between the layers in a horizontal manner. And then our final slide, they talked about geothermal energy, which is a really cool way to get energy, and it's produced by the heat of the earth. Scientists are still working on this. If they can learn more about it, we can get more energy, which we can always use energy for electricity, to heat our homes. So a lot of good could come from this. A lot of more research is needed. So two examples are geysers and hot springs. So they involve water and groundwater, so water below the earth. Once the magma heats up that water, you can get geysers. So I have a picture of a geyser. Yellowstone National Park is one of the most famous ones. So the geyser erupts at regular intervals. So this would be an eruption. There are times when it's really just this little, almost stump-like rock, and then it'll erupt again. Then it'll be nothing. Hot springs are collecting in a natural pool. So you're not having those upward eruptions like a geyser, but still pretty cool to look at in that little pool there. So those were two lessons. Hopefully you took a lot of notes. That'll help you get good scores on both of those quizzes.